Good afternoon, ladies and gentlemen. Today we are going to be simplifying expressions. I want to make sure that you guys understand the correct vocabulary. A variable is a symbol, usually a letter, used to represent a number. So an example of that would be A or B. A coefficient is the numerical factor of a term that contains a variable. So anytime you're multiplying by a variable, that number that you're multiplying that variable by is your coefficient. Constant is a term without a variable. For example, the number 8. No variable with it means it's a constant. Rule: only like terms can be added or subtracted from one another. So example, a constant cannot be combined with a coefficient, and a variable cannot be combined with a constant. So let's take a look at these steps. If they have the same variables, they're like terms. If they have the same exponents, they're like terms. If all are constants, then you have like terms. So take a look right here. We have constant. The number 3 is a constant. Okay. 4 is a coefficient, and x is a variable. There's other constants and variables in here too. We have y, that's a variable, and 2 is a constant because it doesn't have a variable with it. So the next thing we need to talk about is the word term, okay? And terms are basically the addition and subtraction section of this. So you can see you have the number 3, that's a term. 4y is a term, y is a term, 2 is a term, and x is a term. So that means that there are 1, 2, 3, 4, 5 terms in the expression. Terms are separated by addition or subtraction signs. So with the 5 terms there, let's regroup them. Let's use the commutative property to move this stuff around. So 3 is a constant, and 2 is a constant. 4y is a constant, and y is a constant. Oh, I just said that wrong. I do apologize. 4y is a variable with a coefficient, and y is a variable. And even though y doesn't have a coefficient added, like shown, then that means that y has one y to it. And finally, x is a variable all by itself, and that means that there's one x. So let's keep going. So we want to put the like terms together. So that means we can actually add 2 and 3, which you would typically add anyway on a daily basis. 3 plus 2 is 5. 4y and y means we've got how many y's? 4, and then one more makes 5y. And then x all by its lonesome. All right, so let's do some examples. I don't want to do all of these because I feel like we'll get the gist of this if I do 4. So I'm just going to do 4 examples. As a review, it says sometimes when you are doing this, you need to use the distributive property. Anytime you see the parentheses with a number outside of that parentheses, that means multiplication. And when you see that, that's asking you to do the distributive property. So that means you're going to multiply 2 times x and 2 times 3. So 2 times x is 2x. 2 times 3 is 6. Bring the plus sign down. All right, so now we're going to do this again because there's 2 distributive property situations happening in this problem. 9 times 6 is 54, so we get 54x. 9 times 3 is 27. Don't forget to bring down the plus sign in between those 2 distributive properties. Bring down the plus 5. And now we have to look for our like terms. Now, I'm one of those big people that likes to use different colors and box my my like terms and so on and so forth. So that's what I'm going to do today. So 2x has a variable of x. 54x also has a variable of x. So those 2 are considered like terms. All right. And then we have a positive 6 here. So I'm going to circle that in red. A positive 27 and a positive 5. So I get to combine the 2x and the 54x, which gives me 56x. And then 27 plus 6 plus 5. So if you are struggling with doing your math, go ahead and write it out to the side. 27 plus 6, well, that would be 13, carry the 1, 33, plus 5, 38. So then put positive 38. Now, make sure that you're being very careful with your integer rules, because the negative should always go with the number behind the negative symbol. So be very careful with that as you go through this. Let's take a look at this situation. This is, I can tell right now, already has those negative numbers in there, which we need to be careful with. And so as you can see, we have 3x. So I'm going to separate that because I see my distributive property right here. And I need to be able to do my distributive property correctly. And notice how you should see this negative in front of the 1. That means I need to multiply, even though it looks like subtraction. Remember, I told you subtraction and negatives go hand in hand. They use the same rules. So I'm going to multiply -1 by everything inside of that parentheses. So -1 times positive 1x is going to give me a negative 1x. -1 times, well, that's a -5. So I could technically consider that -5 too. So -1 times -5 is a positive 5. And I'm actually going to put the plus sign in front of that so that I have a separation there between my -1x and the 5. Bring everything else down. 3x, positive 9. All right, so now I got to look for my like terms. All right, so I see 3x minus 1x. That's actually one big set of like terms. Look how nicely grouped together they are. So 3x minus 1x is 2x. And there we go with on the right-hand side, a positive 5 and a positive 9. So I'm going to add positive 5 and positive 9, and that's going to give me a positive 14. So 2x plus 14, and there's my final answer, because I have all of my like terms combined. How do I know? 14 is a constant, and 2x is a coefficient with a variable. All three ended up being different terms. All right, let's move on. So I'm going to do the same exact thing. I'm going to separate my distributive property just like I did before. So we have positive 6 times all that stuff. So we're going to leave 18 out by itself. Same thing over here with the minus 3x. So that means I need to do my distributive property again. So I'm going to multiply 6 times negative 7x and 6 times 8. All right, so let me grab a different color. 6 times negative 7 is negative 42x. 6 times 8, 48, and that's a positive 48. So I'm going to put a plus sign in there. Let me make that look more like a plus sign. All right, or an addition. Let's bring down the 18. Let's bring down the minus 3x. Now let's look for some like terms. All right, I'm going to look for variables first. So remember that that negative is going to go with the 42x. And remember that that negative or subtraction sign is going to go with the 3x. So I have a negative 42x and a negative 3x, same signs, use your integer rules, add. So 42 plus 3 is negative 45x. All right, and let's take a look at the other ones that I have. I have a positive 18 and a positive 48. 48 plus 18. Okay, well, they're the same sign, so I get to add them. 16, carry the 1, 4 plus 1 plus 1 makes 6. So I get 66 plus 66. All right, now, do I have any other terms that can be added because they're like terms? Well, constant, variable, coefficient. Nope, everything is different. So I can box my answer and move on to the last one. Notice how this last problem that you see does not have any parentheses. That means there's no distributive property needed. So what you're going to go ahead and do when you're solving this is just look for your like terms. I do notice one thing. I have x's and I have y's. X's and y's, even though they're both variables, they cannot be combined because they're two different types of variables. So let's keep on going. I have 3x, so I'm going to circle that, and I have a positive 2x. Those are like terms. Then I have a positive 9y. I'm going to use a box for that. And then I have a minus y, or a negative y. Now, remember that that negative y is a negative 1y, so I can use that to help me combine my like terms. And then, of course, I have this positive 3 constant out by its lonesome self. Let's go ahead and start filling all this in. 3x plus 2x is 5x. 9y minus 1y is 8y. They're both positive. And then finally, the last piece is a positive 3. And then box your answers. Well, I hope this was very informative for you, ladies and gentlemen, and please make sure that you use these techniques to help you simplify your expressions. Have a wonderful day. Bye.